All right, get yourself organised here. So today we're looking at what's known as other polynomial functions. So we're looking at, when we say other polynomial functions, x to the 4, x to the 5, and so on. All right, so here we've got even degree. So an even degree, what's defined as an even degree is if the highest power of x is even. So examples there: x squared, x to the 4, x to the 6, x to the 8, and so on. So if we just have a bit of a squiz here, so here's a, put that down there. So if I just type in a few things here, so y equals x squared, we know what that looks like. Y equals x to the 4, and we know what that looks like. Y equals x to the 6. Here we go there. And then let's just go y equals x to the power of 10. And there's that one. All right, so you can see the bigger the power becomes, the flatter it comes in the middle here, and the kind of more square it gets there. But they all go through the point 1, 1 and the point negative 1, 1. All right, so we go back to here, and so what we know is all the standard ones, they all go like this. So that might be your x squared one, your x to the 4 one comes, and we got a little bit flat in here. All right, and then bigger will get flatter in here, so that might be x to the 8, for example. All right, so that's what we call even degree or even functions. And then obviously, if we follow the same thought process here for the odd degree, so x cubed, x to the 5, x to the 7, and so on. So if we go and we have a look at, got this here, let's clear all of those. And so let's go y equals x to the power of 3, oops, not u, equals x to the power of 3. We know what that looks like. Y equals x to the power of 5. What do you think might happen here? All right, y equals x to the power of 9, I'll go. All right, so again, for our odd ones, they all start down the bottom left, finish at the top right. They've all got this point of inflection in the middle here. They all go through negative 1 and negative 1, and they all go through 1 and 1. And again, the bigger the power, the flatter there and the squarer here that it gets. All right, so that's all you need to really know is, so we come here, we've got an inflection, bigger power, so that might be your x cubed, your x to the 7, might be something like that, square it in there. All right, so that's all we need to really know about the even and odd degrees. That all even powers look like this. The higher the number, the flatter they, flatter across the bottom and square in the corner. All the odd ones look like this, and again, the higher the power, the flatter across the bottom and the square in the corner. All right, so let's have a look at some other things. So this here, fx equals x minus h to the 4 plus k. So there's similarities here. So we've done with a power of 2 up here, we've done with a power of 3 up here. And so there's going to be similarities. So our h and our k, let's go up to our, here we've got turning points, haven't we? And so for our a power of 2, our quadratic, that told us where our turning point was. All right, and so it's the same thing here with this. So we've got the turning point at H and K. And if that's an odd number there, then it's not a turning point, it's a point of inflection, but we're just doing powers of 4s in this example here, so I'll just talk about that. All right, all the other sort of stuff that we do, finding x and y intercepts, all still the same as we've always done. So let's have a look at a couple of examples. So I'm going to sketch the graph of the function x minus 2 to the power of 4 minus 1. So what I know straight away from that is a turning point. All right, at 2 and negative 1. Straight away I know that. Y-intercepts, I can figure out the y-intercept. So the y-intercept occurs when x equals 0. So y equals 0 minus 2 to the 4 minus 1. Negative 2 to the 4 is 16, minus 1 is 15. So we've got a y-intercept at 15. X-intercepts, as we know, they are when y equals 0. So we've got 0 equals x minus 2 to the power of 4 minus 1. I'm going to add 1 to both sides. So 1 equals x minus 2 to the power of 4. To get rid of the power of 4, we do the opposite. And the opposite to the power of is rooting. And this time it's the 4th root. Now, whenever we are doing even roots, we need to be plus or minus. All right. So we don't have the information to know which one it might be. And also always for even roots, plus or minus. All right, so in this case, what number can you multiply together by itself 4 times to get 1? Well, that's 1. So the 4th root of 1 is 1. So plus or minus 1 is x minus 2. Add 2 to both sides, and so that tells us that x is 2 plus or minus 1. So I've got 2 answers. 2 plus 1 is 3. And 2 minus 1 is 1. So there's our intercepts. So let's squeeze a graph down in here. Like so. So 1, 2, 3. Negative 1. 1, 2, 3. 15's way up here somewhere. Better label my axes. Let's now change our colour of our pen. Do it orange, so we have a y-intercept at 15. We have a turning point at 2 and negative 1. We have an x-intercept at 3 and at 1. So our thing goes like so. All right, so same techniques as we have done before with other graphs. All right, so the other thing you might be asked is to solve some equations for x. So here we've got x to the 4 minus 8x equals 0. And so we want to solve that. So whenever we're solving these, the same as we've done in the past, if it was a quadratic or a cubic, and it doesn't matter, it could be a power of 4 or a power of whatever, we do the same thing. We want to factorize. And so when we look at this one here, we notice that there's a common, x is common. So I'm going x times x cubed minus 8, and that equals 0. So our null factor law then says that one of those two things is equal to 0. or x cubed minus 8 equals 0. Over here with the x equals 0, we don't need to do anything more. So one of the solutions would be x equals 0. Over here, add 8 to both sides, x cubed equals 8. We need to take the cubed root, the 3, right, power of 3, cubed root of 8. What number multiplied by itself 3 times gives us 8? All right, 2, as you've said, all said. And so 2 solutions when x is either 0 or 2, then this equation equals 0. Let's have a look at another one. Here's another one. X to the 4 minus 2x cubed minus 24x squared. So we'll notice here x squared can go into all of them. So I'm going to take x squared out as a common factor. X squared times x squared is x to the 4 minus 2x minus 24 equals 0. Now, I'm going to do something different here than I did in the previous one, because I'm going to factorise this first. I didn't factorise that one. I could have, but because there's no x term in there, it's just as simple just to go and do your solving here. All right, because you could try and factorise that, but you end up with this answer anyway. So because there's no other x terms, it's just the cubic and the 8. It's the simplest, most time efficient is to do what I've done here. But now, because we've got this 2x term in here, I need to have a look and see, can I factorise? So can I have 2 numbers that multiply to give me 24 and add to give me -2? And I reckon -6 and 4 would do the job. So we've got x minus 6 and x plus 4 equals 0. So null factor law says either x squared is 0, in which case x has got to be 0, x minus 6 equals 0, in which case x would have to be 6, or x plus 4 equals 0, in which case x would have to be minus 4. And so they would be the solutions for those. So any one of those 3 values for x would make that sum there equal to 0. All right, so that's it. There's really not much in the way of new stuff there. A lot of those techniques, you know, the factorising, null factor law, finding x and y intercepts, you know, all those things we've done before with lots of other graphs. All right, so it's really just the odd and the even, and that's pretty straightforward. And you just notice the pattern between odd and even and what their graph looks like. All right, so as always, have fun, and if you need help, get back to me.